This is the second half of my talk, and I want to talk about, in fact, I want to show you how easy it is to go from having an idea, having that concept, through to deploying an AI. I think a lot of the times when I see AI demos, talks, things like that, people will go, hey, look, we've trained it, and it's 90% accurate, and then stop. What I want to do with this talk is go beyond that. So I'm going to talk about why, what IBM's motivations are, what my motivations are behind this talk. I'm going to talk about IBM's tool chain. So we've built some really cool tools to enable this. Then I'm going to do a quick crash course on iOS development and go through some of the considerations you might want to think about when you're architecting this kind of solution. Before I begin, anyone in the room an iOS developer? Okay, a couple of people. Cool. You're in for a smooth ride when I do the 101. It's literally one slide. Those of you that are not, do not worry. I just wanted to put it up there to provide some context. So, why? Why this talk? Why deploying AI? So, I mentioned just now that I think a lot of the topics, a lot of the conversations, talks I see on this subject go as far as demoing the training, right? Hey, look, we trained an AI, but nobody uses the training. People use what you have trained. So with this talk, I want to go one stage beyond that. And I think this actually indicates a slightly wider problem, right? And that is around machine learning and deep learning AI in general. And that is there's this skills gap or gulf between the data scientists and your subject matter experts. Right? So your data scientist, the person that understands TensorFlow, gets all of these frameworks, that's great, but actually the person that has that insight is your subject matter expert. And no more is this the case for me, or the obvious kind of use case or example of this is medicine. Right? The person I want training and teaching my system how to classify different types of cancer, how to identify, whether or not this is healthy tissue or unhealthy tissue, right? That person is the clinician that has spent 300 million years understanding that field, right? And has read every textbook. That timeline is not right, but has read every textbook on the subject. That's the person I want giving that insight. The problem is that person, that persona, probably doesn't have enough time to sit there and teach themselves TensorFlow or sit there and teach themselves Caffe. So how do we enable them? How do you enable the subject matter expert to be able to train and deploy these systems, right? I think that to me is one of the key things. So with that, I'm going to talk about tooling to do that job. One of those tools is Power AI Vision. Now, I'm going to show you this in a lot more detail. I'm going to show you it live in a minute. Power AI Vision is a browser-based tool, so it's a browser-based interface that takes you through that entire pipeline for building image and video classification detection models, right? So those kind of common image workloads, that's what it walks you through. Yes, please, that'd be great. Thank you. So it talks you through that kind of pipeline, right? It goes through curating your data set. How do you curate and accurately label your data set from start to finish, right? What tool do you use to do that? It goes through training your model, right? Actually selecting a network to train your model against, all the way up to deploying that model, right? So actually deploying that model so that then users can get their hands on it. By the way, if you've ever gone through the process of trying to deploy a model for one of these workloads, the fact that this tool can take care of that for you, and I'll show it in a minute, is really useful. And it handles both video and image workloads. So it really is about creating that pipeline to enable the subject matter expert, right? To take them through that journey of doing data science without bombarding them with all of the TensorFlow documentation, right? Without making them have to understand Bayesian inference and stuff like that. Let's just enable them to build a model for their specific domain. So that's Power AI Vision. And as I said, it lets you deploy a model as a web API, which I want to talk a bit more about. So this is XHR. Anyone in the room familiar with this? Show of hands. Anyone familiar with XHR? Yeah, a few people, my developers, my iOS developer, definitely. Right, so XHR is XML HTTP request. For those of you that aren't familiar with it, basically it is a web standard protocol for messaging, essentially. What we do is, so in this example, this doesn't quite fit with AI Vision, but most of us, I think, will have booked flights to come here today. here is an example of XHR for flights. So over here we have our client. This is our web browser. For the case of this demo, it will be an iPhone app. So we've got our web browser, and we enter our from and to destination, and we hit search, right? Then what happens is we use XHR to package that up in a special box, essentially, that when it gets to our server over here, where AI vision might sit, our server can unpackage that object and say, okay, yeah, I've got the from and to destination, it's in a particular format, cool, I can then send the response back of those flight times and dates. So that is XHR. Now, the AI vision API is XHR compliant, which is really awesome. It's a REST API. It's really awesome because it means that anywhere where you can do XHR, you can communicate with this API, right? Which is why this talk would work just as well if I were building a website or building an Android application or an iPhone application or, frankly, anything that can use this XHR protocol. If you're writing in a programming language that doesn't use these kind of standard web protocols, I'm sorry. But they're fairly ubiquitous, and it will allow you to integrate these models trained in AI vision really quickly. So that's XHR. The second thing is JSON, not the Jason at the back who's talking later, different JSON. This is JSON. It is JavaScript object notation. The response you get back from AI vision looks a lot like this, because this is a copy-paste of the response you get back from AI vision. What we've got here is this classified field here. In it, we have two things. One, the classification. Laris is a type of seagull. I did a version of this talk in Norway, and at this point, when I was doing the demo, somebody's hand went straight up, and I was kind of naive, and I said, hi, yes, a question, brilliant. And the guy said, that is not a laris, it's a fla, and some other type of bird. So I learnt my lesson. So today we will be using chocolate, where I am a subject matter expert. Next to that, what you get is the classification confidence. So here, this particular seagull, or not seagull, was in the training set, which is why we've got a confidence of 100. But basically, it tells you how confident the model is that it belongs to that category. Then we get the image URL. So it stores the image in this temp directory here once we've sent it, and the final thing we get is the result of our query. So you can handle errors, things like that, if you want to on the client side. I didn't want to, seemed like more work than it was worth. So that's the response you get back from the AI Vision API. iOS application development. Yeah, this really is a crash course. This is a iPhone screenshot. So 3 things you need to know for this talk to make sense. The first thing is that iPhone applications or iOS applications can be written in a language called Swift. Swift is open source actually, but it originated inside Apple. It's really, really cool. You can also write them in Objective-C, a variety of other languages, but I don't like Objective-C, so I've chosen Swift. The second thing is you get this thing called UI Kit. Now, UI Kit brings with it all of the buttons and switches and things you might want for your standard user interface. So here we can see we've got, our list view here, a couple of buttons down the bottom, and our standard navigation controller that we're familiar with from pretty much every standard application. They come in this UI Kit thing. So if I import UI Kit, I also get all these buttons. Really easy, right? The final thing is the iOS network stack, which is the network stack for iOS, so snappily titled. And we're going to use that to actually form our XHR request and package our object up. So essentially the architecture, and I'll go into more detail when we start to look at the code in a minute, but the architecture is we take an image from our camera, either choose image or from the camera, and then we put it in our box, fire it off to the server, get that response back, and then decide how to handle it, right? So if it's a detection workload like this, we populate a list view. If it's classification, then we just write the response at the top of the page. So that is everything you need to know to be an iOS app developer, I promise. So we have to do 2 things. So this function, we can dive deeper into it at the moment, but we have 2 functions. One, I have called choose image from album. Lets you choose an image from the album. The other, choose image from camera. Yeah, you see, I told you it was easy. So this will open up the camera view and let you take a picture and then send that to be classified. You'll notice the only difference between these 2 is the source type. So here we're choosing from the photo library, and here we're choosing from the camera. So even that bit is the same. And then we handle the response of that just by making our query to AI vision. So that's getting images. The second is our network request. So up here, this is where your API URL could go. By the way, for those of you who are planning to go to the hackathon in a bit, all of this code on GitHub. Anyway, so this is where the API URL for your instance could go. Then we set up our request. So we set up some of the parameters for our request. We load our image object up and we get the data from that image. So the actual image itself on the iPhone isn't the PNG, right? It isn't the JPEG. So what I do there is I get the JPEG and then fire it off to the server down here somewhere. So that's what we do. So we get the image from the camera or from our album, and then we make a simple web request, a simple network request over to the AI Vision instance to get that result back. Simple, right? I'm going to prove it with the next 30 minutes. By building a data set in AI Vision, I'm going to cheat a bit there because you don't want to sit and watch me upload Cadbury's chocolates. Then we're going to train a model, deploy that model, then we're going to not build, we're going to clone an iOS app, connect it to the API, and then we're going to test the iPhone app. There's Alaris. That one is Alaris, by the way. Promise. So we're going to test the iPhone app, and we're going to do all that in about 30 minutes to prove it is possible to go from end to end with zero skill in 30 minutes. So that's the demo. Before I go into the demo, there's a few considerations that I wanted to touch on about actually the architecture for these applications. So I've spoken heavily about using the AI Vision API, right? There are times when that's a really good idea and times when you don't want to do that. It's a really good idea because this talk is about AI Vision and the REST API. It is also a good idea because it reduces the development overhead. Right? It meant that I didn't have to integrate the model into my app. So my app size is smaller. So if I'm worried about size on a user's device, then it's really useful to use that API because it means that you don't have a bloated app file size. It's also useful because it means I can change the API and my users get that functionality without me pushing an app update to them. Right? How annoying are those? By the way, you need to update this app bubble that pops up all the time, unless you have an auto update on. But those bubbles annoy me, and the REST API would let you change your model. So say one day we're recognizing Alaris as the incorrect bird. I could quickly change that without disrupting my user's experience. Suddenly they get the new model, right? Or maybe we add a new type of bird into the model. They can get that without disrupting their service. Times when you would not want to use the API. Use cases where your users might not have a network connection, right? Because then doing a bunch of stuff over the network isn't very helpful. Say if they're down a mine or working underground. Or actually, in the case of this bird detection example, they're in a field looking at birds. I don't know how they got them to pose quite like this, but you're in a field looking at birds, taking photos with your iPhone. You don't know that you're going to have a network connection. So maybe the API isn't the route to go down. However, for the purpose of this talk, it is. Also, doing inference, so classifying your image, the inference phase on device is more computationally expensive than the network request for a lot of examples. So if you care about your user's battery at all, right, then actually maybe sending a lower resolution image out over the network is better. So up to you, just a few of the design choices I made. Anyway, as I promised, slightly less time now because I was talking, but we're going to do this demo, build the data set, train the model, deploy it, build the iPhone app and connect it to the API, and then test it in about 30 minutes. So, let's go. Right. So this is AI Vision, for those of you that have not seen it. Has anyone seen AI Vision? Yeah, okay, cool. The IBMers like me. Right, so Power AI Vision, basically, as this, I think this is the homepage for it, kind of illustrates clearly what it does, right? So it's about creating your data set, doing that data prep, so augmenting the data if you need to, adding noise if you need to, and then training the model in one kind of platform, right? And it's about enabling the subject matter expert. So the first place where we need to start is with our data set. There's a few here. You can see varying importance. We've got chocolate here, and we've also got a breast cancer demo as well. I'm going to stick with chocolate because I'm an expert in that. So this is our data set. What I've done beforehand to save you guys is I've uploaded photos of these chocolates. Now, to upload a photo, you can either drag the file here or import the files. Right? If there's one thing we know about humanity at the moment, it's that we're pretty good at uploading images to web browsers, rightly or wrongly. So I'm not going to demo that bit to you, but trust me, it's easy. Then once you've done that, you can select the images that you want to label, and then select assign category or label object. So let's say assign category. And then I can pick the category of my Cadbury's chocolate that is. So they are caramels, so I could select caramel, and then it would assign the label caramel to them, right? So you can see really quickly, I don't need to know everything about TensorFlow or Jupyter Notebooks to classify my data set of whatever I want it to be. I can be a subject matter expert, and I can create this. So the other workload, so this is our classification problem. So there's two workloads that we're talking about here. One is classification, what type of chocolate this is. The other is detection. Where in the image is there this type of chocolate, right? So those are the two workloads. So this one's really easy, right? Because I just select them and I say assign category. But what happens if I want to do detection? Well, on this example, I will show you how easy it is. So let's select our cream egg hero and then label objects. So what we've got here, this is a photo around it. So you can see this blue box. This is the boundary where we have said there is a cream egg hero. So I can delete that, and then I could say, actually, you know what? It is a fudge hero, and I can click and drag around it and let go. And now it is labeled as a fudge hero. However, that is bad data science because it is not fudge hero. So I'm going to quickly undo that. But you can see actually how quickly you can build your data set, right? Either for classification or detection. It's simple. It's a browser-based GUI. And that means that you can get your subject matter expert to do the data science and then hand them the trained finished product to your development team, and they can integrate it into your application, right? So once you've done that for your images, you can select Done Editing. Now, there are a whole bunch of other features that I am not covering because they're kind of out of scope for this talk, but there is a demo booth downstairs that will be running in the breaks and after this, where we can go through things like data augmentation, so we can add noise to your data set. So if you've got a small data set, we can do data augmentation to reduce that kind of noise and any of those biases that might be introduced. And we'll go through some of the more advanced features of this down there on a specific basis. But that is labeling objects for the purpose of this talk. Now, I have my labeled data set. I'm going to go back to this one because it's faster. I have my labeled data set, and now I think, okay, cool, done that. Now I want to train an AI, right, to be able to classify my chocolate. This is like groundbreaking work we're doing here, right? So I want to train this model to do it. So I have this big blue button, train model, right? And then it takes me to this page where I give it a name. It's actually, there we go. And I can choose the type of training, so I can choose classification or detection. This is a classification problem. This is really useful because it means you can use the same data set for both classification and detection problems. You just choose here. Then you choose your base model. There are a few of them. What we do with the base model is make some assumptions about the underlying network. Right? So we can make some assumptions about the best network to train your model with if it falls into one of these categories. So if you notice that things like flowers all tend to look fairly similar. Not a botanist either. So they all look relatively similar. So this will make some assertions about the underlying network to speed things up. What those assertions are, I'm sure we could tell you. I'm not going to tell you in this talk because that would not be fun for me to sit here and read out the differences between them. Or you can pick general. Now, I'm going to pick general because I don't want to make any assumptions about the network. Now, I could click train here, right? And then it will start to train a model for classifying those different types of chocolate for me, right? That's great for my SME user, my subject matter expert user. That's brilliant, right? But actually, I've got another user, right? And that is my data scientist, my person who actually knows what's going on and wants to modify some of the hyperparameters. To do that, I can select advanced options because I'm an advanced user. And I can go through and I can change some of these hyperparameters, right? So I've got the, so this is the, Here we go. So this is the so I've got things like the maximum number of iterations. I've got how frequently I run tests. So against my test data set, AI Vision will automatically reserve some of your training data set to use for validation. Does that on its own, which is great. I can modify the learning rate, my weight decay. I can mess about with all of these hyperparameters to ultimately affect how my end network looks. I can do all that here. In the interest of time, I'm going to say that I want to go through the data 150 times, and I want to test every 10. Now this may not, probably won't, produce a very good network, but in the interest of time, I just want to show you how quick it is to do it. So, back out we go, and I'm going to click Train. So, what's happening now is AI Vision is going to go through the dataset. What this pause is AI Vision is automatically resizing those images, so they're all the same size, they're all using the same color channel. So it's doing the kind of things that a data scientist would probably be doing manually, but the reason it's doing it is to balance the model it then produces. Then it says error, because this is a live demo. If it weren't a live demo, it wouldn't say error. So there we go. But what happens then, trust me, is it trains. Oh, look, that's the failed one. Let's go to one that worked. It trains, and you will see something like this. So what we've got here is our learning rate, the number of iterations, and then, importantly, the accuracy on the validation data set. So the data it kept behind and didn't train it. You also see this graph, so you can see it improving. So if you've got a really steep gradient here when your model finishes training, probably want to either adjust your learning rate or actually look to run for more iterations, right? So this does actually show you some really useful data. So you've got all that there front and center. So it's kind of helpful for those data scientist users, but also shows you how accurate your model is. Anyway, now we have trained, and we've trained our model. We've created our data set. We've trained our model, although we didn't quite because it failed for reasons I will debug after this. The next step is to deploy it. I'm just actually going to delete that model so I can redeploy it. Right, so I go back to my models page. So these are all of the models that I have trained on AI Vision. As you can see, chocolate features heavily. So to deploy it, right, now I'm thinking, all right, so I've done the data science, I've trained my model, and now I need to deploy it, right? I need to get it into the hands of my engineers so they can integrate it into that end application, okay? So to do that, I tick this little box, and then there's this button here which says deploy model. I've got this choice here, deploy and export. If I wanted to export it and deploy it onto a different node, something like that, absolutely could do that. But in this case, I want to deploy it right where it is. So I want to deploy that, and I want to call it chocolate detection model. So let's hit deploy. Okay, so that's it. So what's happening now is it is starting a REST API that will run on this box for classifying chocolates. There we go, it's ready. I'm glad that worked. Right, so it's ready. So I can select it here. I can view its information. I can test chocolates literally here. So I can upload the chocolate and test it. Should we see that? That might be fun. Right. Hub.com. Right, so I have here, by the way, the data sets are open source as well, so if you want 700 photos of Cadbury's chocolates, right, so let's go under chocolate. What we've got under here, so these test ones are ones that I have deliberately kept out of the data set so that I can do this with. So let's screenshot that. Right, and then let's go back to Power AI Vision, go back to our deployed models and pick this image classification model, right? So here we go. So it tells us the accuracy over here, so it's 97% accurate, which is about to have to prove to us, so I hope that's right. It tells us when it was trained as well, right? So I can view whether or not this is the latest and greatest version of my model. So maybe somebody came along with some more data and trained it after this and it's more accurate. Then I can make sure that I'm always on the latest and greatest stuff. Also shows me who created it. So I can have multiple users. So I know, if I know that John is an absolute liability when it comes to training AI, and it says that he deployed it, I can ignore the API. Anyway, so let's drag the caramel over here and let it go. And there we go. God, it said caramel. So what we've got here, it hurt me before. Now, so over here, this is the photo I uploaded. Hopefully everyone recognizes that. We've got our accuracy up the top. And this is the really interesting thing on this chart for me, right? And this is the really useful thing, actually, is this heat map is showing what weight activated, right? So what bits of the image made it say caramel? Handy, because this is the bit of the image that would make me say caramel, right? And that's so helpful because I've been, I had, maybe I know of an organization that had built an AI to classify different types of sandwiches, right? So is this one a chicken sandwich or a bacon sandwich, whatever it is. It was classifying sandwiches. And they built this model and they said, yeah, you know what? It's 97% accurate at classifying different types of sandwich. And we said, oh, okay, let's see. Let's run it through this and see what happened. And it turned out, so we ran it through, and this image, the background, so what is here is white, lit up like an absolute Christmas tree, and the bit where the sandwich was completely blue. And we thought, okay, not sure you're classifying sandwiches. Let's look at the data. So we went through their data set, and it turns out that they had paid an intern, presumably, to take photos of these different sandwiches, but the intern had gone out and taken each photo with a different background. So all of my bacon sandwiches had a blue background, and all of my chicken sandwiches had like a white background, where they'd used like different colored backdrops just around the office when they created this data set. So they'd built a model that was really, really good at telling you the background color in an image, which isn't what they wanted it for at all. So this is a really useful, quick sanity check. Is my model looking for the thing I want it to see? So particularly helpful. Right, so this is it deployed. Now, up here, I have my API endpoint. I could stand here and read to you the full API documentation. I won't. Some nervous-looking faces. To get the API URL to classify against this, I literally just click copy, right? And it adds it to my clipboard. And then I've got my API endpoint that I can integrate into any application I want, right? So let's jump over to the iPhone application development. So this is my storyboard. This is a beach ball. That's a spinning. There we go. So this is my storyboard. Let me zoom out a bit. You will see not massively complicated in that, sorry, there we go, in that I only have a couple of scenes. So I've got my main page, which lets me choose whether or not I'm doing classification or detection or something like that. And then I've got two screens, both of which are pretty much identical. The first one, up here, I've got an image view where I will draw the photo that I take from my camera or upload from my camera roll. Then I've got a label above and below it. The label above it, I will write the classification of the image I upload. The label below it, I will write the confidence. And then I've got a couple of buttons at the bottom for choosing my image. In the detection use case, what I have is an image view and below it a table where I will write the classification and the confidence. And again, the same two buttons that let me choose an image. Right? So super complicated user interface design. I'm your man. Right, so let's go into the code. Let's go for classification first, right? So this one, this is that URL. Let me paste it in. So let's take that out and paste in the new one, which happens to be exactly the same. I was testing this earlier. Right, and we can save that. So this is our code. So up here at the very top, that is really small. Why did no one say? Is that better? Can I go bigger still? How are we doing? We good? Right, so up here I've got my different parameters. So this is where I get the image view and those two labels, just so I get them as properties and I can edit them later on. Here I've got this slightly bizarre line of code. You'd think Apple would handle this automatically, but this line of code will disable the camera button if my device doesn't have a camera. You're thinking, what Apple device or what iOS device doesn't have a camera? The only one is the simulator that runs on a laptop. That is literally the only device I can find that doesn't have one, but that line of code will disable the camera button if there isn't a camera. Then what I do is I set the image ratio, so when you take a photo it squeezes it into that box and doesn't fire my labels off the screen, and I update my labels so that instead of the word label it says something more interesting. Then we've got the URL string, which you just saw me paste in here. We do our setup, blah blah blah, all very exciting, and then this is where we deal with our response. So we get the response back. here, and when it comes back to us, I'm going to delete that line. When it comes back to us, it is just a string. So what I'm doing here is converting that string into a JSON object so I can manipulate it and get the parameters I want out of it. So here where I've handily commented retrieve values from API, what I'm doing is getting the classification label, so what label it thinks it belongs to, and then also the confidence, right? How confident is it that it's that thing? And then convert them both to a string, access the main thread, and then update those two labels. The reason I need to access the main thread there is iOS applications only let you update the UI on the main thread, so I need to jump back over to there. So the network task will happen asynchronously. Good, that's what you want, and then it'll come back to the main thread and update my UI even in the middle of that. Right, that's boring network stuff. Right, so that is, in theory, all the code you need to make this work. Here we are. This is my simulator running over here. What I'm going to do is I'm going to choose image classification. I'm going to choose image classification and then choose image. And then in here, you will see, conveniently in my camera roll, I have some various photos of chocolate. I'm going to pick one, and hey, thank God that worked. So it's come back and told me that it is a fudge, drawn the little fudge in the middle, and it's told me its confidence, right? And it's doing that on a server that is running in our London office. So it sends the image over the network to London, gets a result back, and renders it on the screen. I know this is really simple stuff, right? We're not doing anything that will change the world here, but it's literally that quick to integrate a custom image classification model into an end user application, right? And think of the implications of that. I know this might seem like a slightly trivial example, but I could apply it to absolutely anything, right? What if I'm building an application for the visually impaired who really want to know what type of chocolate they're looking at? And using this simple app, it will let them take a photo of that chocolate and it will speak the name of the chocolate to them using speech to text or something like that. So actually the impact is kind of profound and you can just apply it to whatever you want. All I'm trying to do is show you how quickly you can go from, okay, I've had a really great idea that might use AI, using some really cool tooling, and then deploy it and integrate it into an end user application. So yes, go ahead. Yes. Yeah. Yeah, really good question. So the question from the recording was how many images is a typical customer deployment, and yeah, exactly. And the standard tech industry response is it depends. It depends on a number of different factors. One, how diverse is your sample? So here we're choosing chocolates, which are actually all relatively similar, right? We're looking at things that are the same, roughly size and shape. Maybe the color changes, but it's fairly simple. So for this data set, there's something like 200 images. So it's not a colossal data set. If your problem is more complicated and things are more similar, then you're going to want more data, naturally. There's a really handy chart, which actually the folks from NVIDIA that put together, where they've got the number of images and the proposed level of accuracy, and they say something like thousands of images for a typical enterprise use case will be usable. And then by the time you get to millions of images, you're beating human accuracy. That's their kind of general rule of thumb. So we're talking the order of thousands, which isn't so massive actually when you look at enterprise data. On the question of sitting there and labeling thousands of images, you're right. I don't want to do that either. That's why we get the subject matter expert / intern to do it. No, there is a tool in here which I can show you downstairs that will auto-label your data set. So you tag a few photos of a caramel, train a model on a few photos of a caramel, and then you can fire this off so it labels the rest of your data set, which is really, really powerful. So it means you don't have to sit there and tag every image. You can tag like a sample and then say, okay, now you tag the rest of them, and I will tell you if you're right or wrong, which can expedite that pipeline. Right, so I'm going to be really brave here. And I've not tested this, so let's see if it works. I'm going to literally copy this from the chocolate detection model, come over here to my detection view controller, and so it was already highlighted. It was begging me to try this. Right, I'm going to paste that in there, and then we're going to redeploy. I've got 5 minutes. I've got 5 minutes left, I think. I've got more than 5 minutes. I've got 20 minutes left. I think we've done it early. Well, that'd be good for questions. Right, so object detection. So let's go for this. Let's try it and see what happens. So I'm going to choose an image. And let's pick one with lots of chocolates in it. Hey! Right, so, I mean, no applause, fine, don't worry about it. Right, so there's lots of time, it's 20 minutes, you can clap me at some point. Right, so what we've got here is it's gone through exactly that same process. All we have done is send the image to that other API that you saw me paste in 1 second ago, and the API said, all right, cool, I see cream egg, I see caramel heroes, and this is my confidence, right? Then all I've done is taken those parameters in the JSON response and use it to populate a table. And then just to kind of show off a bit, I've also done some drawing and drawn the green boxes around the objects. Let's dive into the code. It's not massively complicated. So all this stuff is the same, right? Literally, I pasted it. But so this is the bit where we set up the request. The only thing that's changed is the endpoint, right? Then the bit that is slightly different is where I handle the response, where I handle the output I get back out the other side. So I've got this array here, my objects detected array, which starts as empty, and that's why that table is empty at the beginning, right? I've got no objects in that table. Then what I do is I convert my response to JSON as possible, as before, from the string. By the way, if I don't get any classifications back, I don't crash, is all this says. Right, so down here, what I'm going to do is retrieve the values from that API. So the API basically comes back with this long JSON array that says, okay, this is the classification, this is the confidence, and then conveniently, this is the xmax and xmin for all of the images, right? So here we've got the coordinates basically for those green boxes I've drawn, right? And that's cool too, because if I wanted to make it more complicated, what I could do is have it so that I could then click on those, and maybe it would give me a description of the thing it had seen. Or, in this case, I could draw a big green box around it. So, I've got another class here, which basically says it's called object detection classification, because I'm really good with titles. Basically, all it does is it holds those different parameters, so I can get them back in a second when I need to fill my table. So what I've got is the label. I'm storing the label. I'm also storing the confidence, and I'm formatting it into that percentage here. I'm doing it here because I didn't want to do it on the UI thread. I wanted it to happen as the data came back, because it's actually really quick just to move that float across. Then I'm storing my the xmin, the ymax, the ymin, all of those different values in this object. Then I'm adding that object to my up here, my empty objects detected array, and then I'm moving on. Right? So I'm iterating through that whole JSON response. For every classification I've got, I'm creating an object that is one of those object detection classifications, and then I'm putting it in this objects detected array. Right? Once it's there, what I do is I go back to my please can I have the main thread, please. What I do then is I update the table view data. Right? So the table view basically understands its data type, understands what data it can be passed, and will do all of that heavy lifting for you, right? So I just say, this is a table view, this is your data, and then when I want to, I say, right, now reload your data because I've updated it, right? So you can do that as frequently as you want. In this case, I'm just doing it once all of the classifications have come in, but if you wanted them to render one at a time, I don't know what that use case is, but you could do that. Right, and then the final step here is I draw on my image. So I get my image view, and then I call this function draw detection rectangle on image, which draws the detection rectangle on the image and passes it the images from that array. Right. So this is what happens. Basically, I get the x and y coordinates and set the height and width of my box and the start coordinate, and then say, okay, get my current rendering context and draw the image with this draw function, right? So it draws it here with these text attributes. The other thing I do, which you will see, is I get the text attribute is I get the label and put the label in the top corner. So if we go back to this, I've also drawn the label on each box. Otherwise, you just end up with a bunch of green boxes around things, and you don't know what it thought it was. So, so I also get the label back and draw it in the top corner, and then I return that as a new image and render it back on the screen. So that is literally all that goes on. It's really simple code. It's not really complicated, and that's kind of the point of this talk, right? Is that it's really, really simple to go from that idea, that core concept, through to deploying it and integrating it into an app that people can have in their hands for classifying chocolate. This app is in the App Store for classifying chocolate. So if you're thinking to yourself, I really wish I knew what Cadbury Hero that was, you can search for Chocolate AI on both the iOS and Android App Store and get yourself a copy of it. And actually, because there was a Friday where I didn't have much on in the office, I also did beer. So if you want an AI that will classify your different types of beer, please go ahead and download Beer AI, and it will just use exactly this REST API to classify your different beers. Disclaimer on that, by the way, because I mentioned that at a couple of other conferences, and guaranteed over a drink this evening, someone will come up to me and say, this beer isn't in the app. I know, I'm sorry. It's like the beers I had in the office. It's the beers that the local Tesco's or Sainsbury's or other supermarket sold near the office on a Friday afternoon. That's the beers that are in there. So there might not be any of the Amsterdam favourites, although Heineken is in there. So feel free to download Beer AI and give it a try later on. If it doesn't work, please don't come and tell me, unless you are carrying a beer for me, and then please come and tell me that it didn't work. Right, so that's kind of the demo end to end. Just before I finish, as we've got plenty of time, I'm going to choose another image. This one with noise in the background, and see what happens. So that worked. So what we've done, exactly the same thing. It's gone through and it's classified the images. One of the things that's really interesting on this, depends on how knowledgeable you guys are about Cadbury chocolate, is that the Whisper and the Dairy Milk are both really, really similar. They're both purple, with the only difference being that one says Dairy Milk on it and the other says Whisper. The AI actually does get those confused really often. It mixes the two of them up because they're really similar. The others, brightly coloured packaging, really distinct, it's really easy for. So when we go back to the question that I had earlier on about how many images you need, and my answer was it depends, it does. And it depends on the class and how similar the class is and actually the problem you're trying to solve for. So there's kind of lots of nuances. But actually this tool, the AI Vision tool, makes it really easy to kind of pick those up. So I will finish with this. The code, all on GitHub, github.com/ChrisParsonsDev/vision_iOS. You get all the code, and not much of a README, but you get all the code to go and get access to this and do what you want with it, right? Do something really, really cool with it that is not detecting Cadbury's chocolates. Right, so that's it. The only thing I will put up is just this slide, because I bothered to build it, so you're all going to see it. Just the thank you slide. And just to finish with, you guys have been great. Thank you so much for coming along. There's a few links on here if you want to get access to the code, samples like that, any of that. And if you're wondering where to go next, there is a hackathon a few rooms down. Go there, do this, do better than I did with Cadbury's chocolate. But yeah, thank you very much for listening.